So I'm going to say this. Consider a geometric sequence. Now, when I say sequence, geometric sequence, we're talking about section 11.1 in the book. And the one I just put up here, 1, 1/2, 1/4, 1/8. And how am I getting the next term? I'm multiplying the previous one by 1/2. Or, I guess you could say you're dividing by 2, but I'm multiplying by 1/2. And this geometric sequence, I can get a geometric series. So, from a geometric sequence, we can write a geometric series. Like the sum as n goes from 0 to infinity of 1/2 to the n. What if I started n at 1 for this problem? It would be, if I start n at 1, n goes from 1 to infinity, then I have to adjust that little exponent. It would be n minus 1. And they're both geometric series. For a geometric series, it's going to converge if the number you're multiplying by is between -1 and 1. Not including -1 or 1. So here's a little summary of this. This is actually on page 710 in your book. The geometric series, the sum as n goes from 1 to infinity of a times r to the n minus 1 is convergent if the absolute value of r is less than 1. So I would say this. So -1 is less than r is less than 1. And if it converges, if the geometric series converges, then we can find a formula for the sum. If a geometric series converges, then I can say the sum as n goes from 1 to infinity of a times r to the n minus 1 is going to equal a over 1 minus r. And if the absolute value of r is greater than or equal to 1, so I'll put this also without absolute value. So if r is less than or equal to -1, or if r is greater than or equal to 1, the geometric series diverges.